You're watching the Weiss channel. Dat. All right. Once again, we're going to go with calculating standard deviation, but we're going to actually do what's called analyzing the data. All right. So this is going to be very easy because we're going to do exactly what we did before. And I'm going to show you exactly what's going to happen. Here we go. All right. So you're going to have a problem that looks like this. Okay. For the following set of data, find the percentage of data within two population standard deviations of the mean to the nearest tenth of a percent. Okay. No problem. Here's what you're going to do. All right. Just like you did in the last assignment, you're going to copy values for calculator. Okay. Open statistics calculator. Okay. Go ahead and paste the values, and the values show up. Okay. Once again, you go to the calc menu, and once again, you go to var stats, and once again, with a frequency table like you have here, right, in this problem, you're going to put L2. If you just have a list, just use the L1. Okay. And then click calculate. Now, for these problems, you're going to need X bar is the mean. This is the mean of the data. The mean of the data means you take all of these numbers, you take 130, you take 732s, you take 1034s, 1536s, 1237s, 739s, and 145. You add them all together and you divide by how many there are. And by the way, look, it tells you that n is 53. So you would divide by 53. But you don't have to do that because it calculates it for you. Okay. So you have this, the mean is 35.77. Okay. Now, since we're doing population, that's this sigma x. Okay. So we're going to use 2.54 for sigma x. Okay, that's the standard deviation. All right. N, the number is 53. We're going to come back to N in a little bit. All right. So here's what's going to happen. The numbers that you need are the X bar right here, which is the mean. That's 35.77. Standard deviation is the 2.54 and N is 53. So we're going to take those numbers, okay? Start with X bar, the mean, okay? The mean, see right here, is 35.77, okay? If I add, see 2.54, if I add 2.54, I get 38.31. If I subtract 2.54, I get this 33.23. Okay, so now I have +1 standard deviation and -1 standard deviation. If I add another 2.54, I get 40.85. If I subtract another 2.54, I get 30.69. The whole question is this. Okay. Question is this. How much of this data, how many of these numbers fall in between this 30.69 and this 40.85? Okay. Well, is 30 in between 30.69 and 40.85? No. Is 32? Yes. 34? Yes. 36? Yes. 37? Yes. 39? Yes. 45? No. So in other words, okay, hold on. Oh, sorry. Here. In other words, here's the deal. All right. Within 2 standard deviations, all right, from 30.69 to 40.85, those numbers are in blue. See, 32, 34, 36, 37, 39. You're going to add these numbers. There's 7 32s, 10 34s, 15 36s, 12 37s, 7 39s. Or frankly, here, this 30 and this 45 is not included. If I take 53 and subtract these two, I've got 51, right? Or you could add all these numbers and get 51, okay? 51 divided by 53 gives you 96.2%. If you do 51 divided by 53, you'll get 0.96226. To the nearest 10th of a percent was the question here. The nearest 10th of a percent. Okay, over here, it said to the nearest 10th of a percent. All right. To the nearest 10th percent would be 96.2. Okay. Some of your questions will just say how much data is there? And your answer would just be 51. That would be it, 51. Because you would add these numbers in blue and you're done. 51 would be the amount of data within 2 standard deviations. Okay. Some questions will ask within 1 standard deviation. If you want to know within 1 standard deviation, then you would just go from 33.23 to 38.31 and add those numbers together. If it asks for a percent, you would take that number and divide by the total. In this case, 53 total is your N. Okay, that's how you're going to do these problems. You've been watching the Weiss channel.